Stray voltage emanates from a variety of sources: a nicked underground cable, leaking pad mount transformer, a neighbor's electric hot water heater, which is much more common than people realize. Stray voltage takes the path of least resistance, wet over dry. If you have a pond on your property simulated by this cup, stray voltage would energize it. Likewise, if you have a pool on your property, the stray voltage would energize that as well. However, fiberglass and vinyl liner pools are non-conductive shells and therefore insulate the body of water from the stray voltage. It can't even see the water. A concrete pool, shotcrete or gunite, is highly conductive when wet, so the stray voltage would energize that pool, except for the fact that almost all concrete type pools are generally reinforced with steel rebar. This rebar grid creates an equipotential plane around the body of water, similar to a Faraday cage. It prevents the voltage from entering the pool. The stray voltage can hit the outside of the cage, travel around it, and then on its merry way, but it can't pass through the plane. For these reasons, the pool's body of water is almost always protected from stray voltage. Prior to the 1990s, pool builders would generally construct the pool shell, then grade around it for the deck, create a structural steel grid, and chair it so it's fully encapsulated when a concrete deck is poured. Sometimes they would lay the grid on the ground, pour concrete, then reach in and pull it up to the middle. This sufficed for structural reinforcement. Since all metal around the water has to be bonded, the equipotential plane in the deck was simply an extension of the one around the shell. Therefore, both the pool and the deck were protected from stray voltage. Sometime around the 1990s, pavers became more popular for decking. There's no need for structural reinforcement of a paver deck, and the structural steel would rust away quickly regardless. Also about this time, fiber-reinforced concrete, sometimes called fibercrete, became popular. It was no more expensive than standard concrete, but sufficiently strong enough to support swimmers walking on a pool deck. The pool builder had discovered a way to save about $500 per pool by not having to tie and chair up rebar grid in the pool deck. However, both the paver and concrete decks now created a new problem. There is no more metal grid in the deck, and it left pedestrians on wet decks subjected to the negative effects of stray voltage. Additionally, sometimes in coastal areas with harsh environments, builders would utilize epoxy-coated rebar in the pool shells, preventing it from rusting away as quickly. Again, swimmers were left unprotected from the effects of stray voltage. As numerous reports indicated, swimmers were getting shocked touching the bottom of the pools, in the pools touching the deck, and simply standing on a wet deck. In the 2005 version of the National Electrical Code, Article 68026 was written to correct this problem. If a structural steel was unavailable, like a paver deck, or encapsulated in a non-conductive compound like epoxy, a copper grid was to be used to provide protection from stray voltage. This copper grid was to be constructed from number 8 solid bare copper wire, welded or connected with listed connectors to create a 12-inch by 12-inch grid pattern. This was to be installed around the entire pool shell and the first 3 feet out from the inside edge of the pool's perimeter surface. All persons in the pool and on the deck would now be protected. It is opined that builders objected to not being able to save money on deck construction. So the NFPA code-making panel, in an unprecedented action, yielded to their direction of simply allowing a single wire in the deck to bond the deck and capture most voltage gradients. But that was proven to be an errant decision, as it was totally ineffective. Concrete behaves like dirt. You can't bond dirt, and you can't bond concrete. You must create an equipotential plane from a metallic grid, and a single wire obviously does not. The mounting evidence to eliminate the single wire option culminated in 2022. The 2022 U.S. Coast Guard report on electric shock drowning included 3 deaths resulting from stray voltage on pool decks, which lacked an equipotential bonding grid. Also, 2 homeowners in North Carolina built new pools, and both were getting shocked on the decks so badly they were unusable hazards. These homeowners obtained an attorney to put the NFPA on legal notice their electrical code was insufficient and dangerous. While the NFPA does not write the code, they are simply arbiters of the process. NFPA management guided the attorney through the process of having a change made to require a proper equipotential bonding grid in the pool deck as they do in the pool shell. The 2023 NEC was changed in April of 2023. There are three options to create an equipotential plane in the pool deck. One option is a W2O by W2O welded wire sheet. This option is rarely, if ever, used. The next option is a minimum number 3 tied rebar. There are three options to create an equipotential plane in the pool deck. One option is a W2O by W2O welded wire sheet. This option is rarely, if ever, used. The next option is a minimum number 3 rebar tied in a 12-inch by 12-inch grid pattern and chaired up to be fully encapsulated by concrete. This is an electrical code requirement, not a structural code, so it must be chaired. No longer can it be pulled up after the concrete is poured. The third option is a welded wire grid of number 8 solid bare copper wire, constructed in a 12-inch by 12-inch grid pattern. By January 1st, 2025, the copper grid must be a listed product. All three options are available for poured concrete decks, but the copper grid is the only solution for paver decks or accessible natural ground. Peruse our site for more content. Email or call any of our technical staff here at CMI for further information.